Hello everyone. So what we are going to do today is we'll try to understand what is called the sign convention. In class 10th and 12th physics, it is a very important topic, fine, and a very, or I should say, a very important concept. In class 10th, in the chapter of light, reflection and refraction, and in class 12th, ray optics, sign convention is extremely important. Now, what exactly is sign convention? Basically, when you try to solve a numerical problem in uh, in the chapter of light, let us suppose that we have a concave mirror. Fine. Now we have the focus and the center of curvature. We have the object somewhere about here. Let's call the object AB, and we have an image somewhere about here called A dash B dash. So far, so good. Now, if you have to tell that what is the object distance, what is the image distance, what is the focal length, and what is the center of or radius of curvature, you will have to give it a name. Fine. You'll have to give it a name. So, for example, the object distance, you can name it as PA. The image distance, you can call it PA dash. The focal length, you can call it PF. And the radius of curvature, you can call it PC. So far, so good. But now comes the tricky point. What are the signs of these four parameters? Is it positive or is it negative? Now, if you go through NCRT and some other books, you know, publishers which are pretty much available on the net, in the market, you'll see they follow something called a Cartesian coordinate system. And in this Cartesian coordinate system, what they do is they will assume that the mirror has to be on one particular side, and the image has the object has to be on another side, and so they will name it. But if in the question the mirror is facing a different direction and the object is facing a different direction, then what you have to do is you'll have to change the signs accordingly. So that means you'll have to actually remember that by changing the side of the mirror, or the lens for that matter, you have to make a change in the signs. And through my experience in board checking, fine, where I've checked a lot of answer sheets in class 10th as well as in class 12 board examinations, I have seen more often than not a vast majority of students make a mistake, and the mistake is usually in putting up the signs. Why? Majorly because in the Cartesian coordinate system, the change of the sides creates trouble. Plus, there are more, parameters to be remembered, to be mugged up than it is required. So in class 12th, there is a particular sign convention which I believe is actually the easiest one to remember and to apply. And it can be also applied in class 10th for both lenses as well as mirrors. So let us see how we can apply this sign convention. Okay, so just let me put this thing up. Okay, now on the board, on the screen, you can see. So let's draw a vertical line here, and let's draw a horizontal line. The vertical line represents either a lens or a mirror. So this sign convention is applicable to both lenses and mirrors. If it is a lens, then the center of the lens is called an optical center, denoted by an O. If it is a mirror, the center is described by P, which is the pole. So O becomes the optical center and the P is the pole, where L is the lens, M is the mirror. And for the purpose of understanding, this horizontal line is your principal axis. Fine. Now, let me first put down the two rules in this sign convention. There are only two rules. Fine. Rule number one says all measurements should start from the pole or the optical center. What does that mean? We'll see in a while. And the second rule says all measurements made in the direction of incident ray are positive, which means the rest are negative. And that's it. These are the only two rules you have to remember. Now let us see how these two rules are applicable. Fine. So let's take some examples and try to see how these two rules are applicable. So example number one, let us say I have a concave mirror. So we have got the principal axis. Here is the pole. Somewhere here is the focus and somewhere here is the center of curvature. Imagine the object is kept here. Let's call the object A, B. Now if the object is here, the image will be somewhere about here. Let's call it A dash, B dash. So rule number one, first of all, we have to name the objects, the parameters. So the object distance. How do we name the object distance? Now the object distance is the distance of the object from the pole. So mathematically, I can write it as PA or I can write it as AP. It's a line. So I can write it AP or I can write it PA. Both seems correct, isn't it? But here, remember rule number one. What does rule number one say? Rule number one say all measurements should start from pole or optical center, which means we have to take this as the correct name of object distance, and this is wrong. So the object distance is PA, starts from P, goes towards A. Rule number one, keep in mind. Okay. Now, the image distance. So again, we have choice. We can call it PA dash or we can call it A dash P. But rule number one, all measurements should start from P or O, which means this is correct, this is wrong. I hope you see the pattern. Similarly, when it comes to focal length, so we can write it PF or we can write it FP, but according to rule number one, it should start with P, so that is correct, this is wrong. Same goes with the radius of curvature. We can call it PC or we can call it CP, and as you must have understood the pattern, PC is correct. Okay. So I hope you understand how rule number 1 is applied. Now let's go to rule number 2. So we know PA is the object distance. And what is the variable we use for object distance? It is U. For the image distance, PA dash, we call it V. For the focal length, PF, we call it F. And for the radius of curvature, PC, we call it R. But what about the signs? Positive and negative? Now we have to go to rule number 2. Now, think about it. If the object is this one, then the incident ray will be in this direction. So this is going to be the incident ray. Fine. So the incident ray is going from the object towards the mirror. Now how have we named it? The object is named as PA. That means when we are measuring the object, it is going from P towards A. But the incident ray is opposite. It is going from the object towards the mirror. So these two are opposite to each other. What does second rule say? All measurements made in the direction of the incident ray are positive. But this is not in the direction of incident ray, it is opposite. Hence, it will become negative. So what is the image distance? Incident ray is in this direction. The name of the image distance is PA dash. Again, starts from P, goes towards A dash. Opposite direction, hence negative. What about the focal length? I hope you understand the pattern. PF, and the light is going in the opposite direction, so negative. And if the focal length is negative, the radius of curvature has to be negative. And tada, we've got the signs. Let's take another example. Okay, now again we take care of a concave mirror. We've got the principal axis, the pole, the focus, the center of curvature, but now the object is kept here. And from ray diagrams, you must have realized that this will be the image. So starting again, what is the name of the object distance? Remember, starts from P, so it will be PA. Name of image distance, rule number 1, starts from P, so it's PA dash. The focal length, rule number 1, starts from P, so it's PF. Radius of curvature, rule number 1, starts from P, so it's PC. Now let's put up the variables U, V, F, R. Now the incident ray is in this direction, so this is the incident ray. Let's look at object distance. Goes from P towards A, but this arrow is opposite to the incident ray, hence negative. Image distance goes from P towards A dash. Now see, this arrow and this arrow, they are in the same direction. Hence the image distance becomes positive. In the last one, the image distance was negative, but here it becomes positive. Focal length from P towards F. That is how we are measuring it. See, PF. So from P to F. But where is the incident ray going? Opposite direction. Hence, negative. And if focal length is negative, radius of curvature is going to be negative. Fine. So just two laws, two rules. All measurements should start from pole or optical center, and all measurements in the direction of incident ray are positive. Just these two rules. Absolutely doesn't matter where you've kept the object. Is it to the left of the mirror, to the right of the mirror, top of the mirror, below the mirror? Doesn't matter. So if the position changes, you don't have to wreck your head and think about how you're going to change the sign. No, no, no. Not required at all. Let's take another example. Okay. Imagine we have now a convex mirror. So we've got the focus here, with the center of curvature here, the object is kept somewhere here, and the image will be somewhere about here. So here's the object, here's the image, here's the pole. Let's do the exercise. Object distance. The name, rule number 1, has to start from P, so it's PA. Image distance, rule number 1, starts from P, so PA dash. Focal length, rule number 1, starts from P, so PF. Radius of curvature, rule number 1, starts from P, so PC. Let's put up the variables U, V, F, and R. And now let us see what are the signs. So let's draw the incident ray. So this is the dash. Oopsie, my bad. Um, okay, so I think we can put this. So because this is the object, so this is the incident ray. Okay, is the incident ray. So let's start with the object distance. PA. PA means starts from P, goes towards A. But you see the arrows are in opposite direction, hence object distance is negative. Image distance. PA dash. PA dash. This and this are in the same direction, hence positive. Focal length. PF starts from P, goes to F. Again, this and the incident ray are in the same direction, hence positive. And if F is positive, R has to be positive. So isn't it a simple one? Just remember two rules and apply them. Obviously, you'll have to do some practice in order to get used to it. But once you're used to it, it's absolutely simple. Now, let's take the case of lenses. Imagine we have a convex lens. Pardon my diagram, it's not always very good. So here is the optical center. Here is focus f1. Here is 2f1. Here is the second focus f2, and we've got 2f2. Imagine the object is kept here. Let's call it AB. Where will be the image? It would be somewhere about here. Let's call it A dash B dash. Fine. I think the image will not be here. Let us say the image is here. Okay. Let's call it A dash B dash. So let's name it object distance. Remember first law, all measurements have to start from pole or optical center. In this case, in case of lenses, it's optical center. So object distance is OA. Image distance OA dash. Focal length. Now here's the tricky part. In mirrors, there's only one focus and one radius of curvature. In lenses, because there are two refracting surfaces, hence there will be two focus. So you have to be careful. Look at the incident ray. This is the incident ray. So on the surface on which the incident ray falls for the first time, that surface and the curvature of that surface is taken to figure out the focus. Now, if the surface is curved in this direction, this will be the primary focus and this will be 2f1, not this one. Okay, it will be on the other side for convex lens. So the focal length will become OF1 and the radius of curvature, although it's not called the radius of curvature, but still it is called O2f1. Fine. Let's name it UVFR. So let's start putting the signs. Remember, now we have to move to the second rule. The second rule states all measurements done in the direction of incident ray are positive. So OA, I'm going from O towards A. You can see the arrow directions are opposite, hence it is negative. Image distance, it's OA dash. From O, I'm going towards A dash. This arrow and the incident ray arrow are in the same direction, hence it is positive. The focal length, OF1. Again, the incident ray and the this particular ray are the same direction, hence positive. And the radius of curvature is O2f1. Again, the directions are same with the incident ray, hence positive. So whether it is a lens or whether it is a mirror does not matter. This sign convention is applicable everywhere. There is another rule. Um, I actually don't call it a complete rule, it's like half a rule. And that says that if this is the principal axis, then anything in the positive y-axis will be positive and anything in the negative y-axis will be negative. So there's positive, there's negative. This rule is applicable only and only when you have to find out the height of the object and the height of the image. So for the time being, you can neglect this. The most important are the first two rules. I hope you have understood a little bit about it. So thank you. We'll meet again next.